Hello everyone, my name is Karan Mashru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is candy. First of all, let us start by understanding the question. What does question say? There are n children standing in a line. Each child is assigned a rating value given in the integer array rating. So we have n children and each child has a ratings associated with them. You are giving candies to these children subjected to the following requirements. So I want to give candies to these children and I need to fulfill these requirements. Each child must have at least one candy. Everyone must get at least one candy. Children with a higher rating than its neighbor get more candies than neighbor. So if let's say there are two neighbors I and J, or let's say I and I plus 1. So if the rating of I is more than I plus 1, then the number of candies which I should get should be strictly more than I plus 1 index child. Okay. Return the minimum number of candies you need to have to distribute. So what are the minimum number of candies that we need to distribute such that these two conditions are hold true and the number of candies which we distribute is also minimum. So for n equals to 3, if the ratings are 1, 0, 2, the output is 5 because you can give 2 candies to the first child, 1 candy to the second child and third child 2 candies. So each of them have 1 candy each, at least 1 candy, and the rating of 1 is greater than 0. So this guy has more candy than this and this rating is also more than this. So this guy also has more candies than this. Okay. Similarly, here you can have a look. You don't need to read input or print anything. Your task is to complete the function minimum candy, which takes the integer n and the integer array ratings as parameters and returns the minimum number of candies you need to have to distribute. The expected time complexity is big O of n and expected auxiliary space is also big O of n. So now if we think about solving this problem, then you see here we need to keep two things in mind. First is each child must get at least one candy. And second is if the rating of I is more than I plus 1, then the number of candies of I must also be more than I plus 1. Okay. Or the rating of I is less than I plus 1, then the number of candies which I plus 1 gets must also be more than I. Okay. So if a neighbor has more rating than the other neighbor, then the neighbor which has more rating must get more candies. Okay. So the example which was given in the question 1, 0 and 2. So here this guy was given 2 candies, this was given 1 candies and this was given 2 candies. So the total number of candies given is 5 and I need to minimize this only. Okay. Now you can have a look here. Here using 4 candies you cannot distribute all of them. Okay. And keeping the constraints in mind. But you look here, why they have asked minimum candies? Because here if I say I gave 10 candies to this person, 8 to this person and 10 to this person, then this is also valid in the condition that everyone gets 1 candy and the neighbor with higher rating has more candies. But here the total number of candies is 28. Okay. And there is no upper limit. So that's why we have asked using how many minimum candies can I satisfy this condition. So how can we solve this is, see what you need to do is, you must traverse from left to right, and if the left neighbor, see, if the left neighbor has more candies, then due to that you increment your candy such that it is more than your left neighbor during the first traversal. During the second traversal, you do the same thing for your right neighbor. If your right neighbor has more ratings, in the first run, what you will do, you will check if your left neighbor has more ratings, then you will say that you will take 1 more candy than the left neighbor. Okay. Because you need more than them if your rating is more and the total should be minimum. So you will take only 1 more. And in the next loop, you will see that if your right person has more rating, then you will, or less rating rather, then you will take 1 more candy than the right person. Okay. And when you do once from left to right and right to left, then it will give you the minimum number of candies which you need in order to satisfy the constraints. Okay. So let's have a look at the smaller example. So if I have 1, 0 and 2. So first of all, what I will do, I will distribute 1 candy to each of them. Now I will traverse from left to right and I will see if the left child has less rating than me, then I will increment my candy if it is less than the left child. So for example, the rating of 1 is 1, there is no left child. This person has rating 0 and it is not more than 1. So I will not increment this candy. Okay. Now here the rating is 2, which is more than 0. So I need to increment this. Okay. So now this has more candies than this. Okay. Now I will move from right to left and I will see if my right child has less ratings. So there is no right child for 2. For 0, the right child is 2, but it does not have less rating. So I will not increment this rating. For 1, the right child is 0, which has less rating. So I will increment my number of candies to the number of candies with 0 have plus 1. Okay. So this will become 2, this will remain 1 only, and this will become 2, and this is what we are required. Now let's try to solve the same thing here. So first of all, assign 1 candies, or let me rather take this to a bit right side. Okay. Yeah. So first of all, I'll assign 1 candies to each, because minimum I need to assign that much. Okay. Now I will move from left to right, and if the rating of left, okay, so if rating of I minus 1 is less than rating of I, then I will say answer of I is equals to answer of I minus 1 plus 1. Okay. Because I should have more candies than I minus 1. So I will say the number of candies which I minus 1 has plus 1. Why plus 1? Because we want to take minimum number of candies. Okay, so if I want to increment the number of candies then I minus 1, then I will increment it by only 1. Okay, and this is the answer array. Okay, for example. So now there is no left child of 1, so this will remain 1 only. Now for 4, 1 is the left child which has less rating, so I will increment the number of candies. For 3, the left child is 4, its rating is higher, so I will not do anything. For 2, left child is 3, its rating is higher, so I will not do anything. For 8, the left child is 2, its rating is lower, so I'll increment the number of candies. For 6, the left child is 8, rating is higher, so I'll not do anything, because if the rating is higher, my number of candies should be less than this only, right? So I will not increment it. For 2, left child is 6, so I'll not increment the candies. For 4, the left child is 2, so I'll increment the number of candies. For 10, the left child is 4. So now the number of candies which 10 will have will be number of candies which 4 have plus 1. Okay. So this will become 3 through this formula. Now here I have taken, I think, one extra one. So I'll just rub it out. Now this person has 2 ratings and this has 10. So the number of candies will remain 1 only. Now I will traverse from here. And at present, what were we seeing? Whether left child has less candies or not. So I was comparing 8 with 2 and was incrementing the candies for 8. Now I will compare with the right child. So there is no right child for 2. So this will remain 1 only. For 10, the right child is 2. So the number of candies which 10 should have should be more than 2. But it already has more. So I'll not do any changes. 4 is less than 10. So it should have less candies only. So I'll remain 2. 2 is less than 4, so this will also remain 1. 6 is more than 2, so the number of candies which should be here should be 1 more than this. So it is 2, okay? 1 more than this, or it is already more. For example, here 10 has rating more than 2. So its rating is already 3. Now you cannot decrement it, because this 3 came because of the constraints here. This guy was 4 and this guy was 2, so this 3 came. Now I cannot make it to 2. So if the right child rating is less during the second loop, and if the number of candies of ith child is less than I plus 1, then I'll increment. Here it was already more than 1, so I didn't did anything. But here it was 1, but it should be more than this, so I made it to 2. Now this person has rating more than this, but the number of candies are same, so I'll increment it by 1, so it will become 3. Now this is less than this, so I'll not do anything. This is more than this, so the number of candies should increase. This is also more than this, so the number of candies should increase. This is less than this, so I'll not do anything. Now if you see, your both conditions are matched. For example, 2 is on the middle. Both the neighbors have more rating, so the minimum number of candies assigned to 2 is 1. For 3, the number of candies is 2, which is more than this person but less than this person. Okay, so this is the minimum number of candies. Now you just need to sum up these values and return this sum. Okay, and that will be your answer. Now let's look at its actual implementation. So if I look at the actual implementation, so I have taken n is the given in the input as the total number of children, and this is the ratings. I have taken one answer array which will denote, answer of I will denote number of candies given to the ith child. I have taken sum equals to 0, which will store finally the number of total number of candies. Okay, and initially I have marked answer of I as 1 because every child will get 1 candy. Now for I equals to 1 to n, I will check whether the rating is more than the left child, then the number of candies will be number of candies of the left child plus 1. Now I will move from right to left, so from n minus 2 to 0. And if the rating is more than the right child, here I was checking with respect to left child, here I am checking with respect to right child. And if answer of I, number of candies with the ith child, is less than or equal to number of candies with the right child, then I will say number of candies with the left child must be number of candies with the right child plus 1. It might be possible that this child already has more candies than the right child, like how we saw in the example. Okay, and then finally this will give me the minimum number of candies each child should have, and finally I'll make the sum of them and return the sum. What would be the time complexity? It would be big O of n, because I am using 2 for loops. Okay, and what is the auxiliary space? The auxiliary space required here is also big O of n, because I am using this answer array of size n. Now let's submit this code. Okay, so let's submit it. Okay, so we have solved this question successfully. I hope you understood the solution completely. Thank you.